All right, today's lesson is about adding and subtracting rational expressions with unlike denominators. Yesterday, all the problems we did had like denominators. These problems will not have like denominators. We'll have to make them be like denominators somehow. And I'm going to show you how to do that. All right, so for these first four problems, we're just going to practice finding the least common denominator. We're not going to actually add or subtract. We're just going to practice the way we find the common denominator. All right, so it's really just an extension of the least common multiple thing that we worked on in previous lessons. So really, if you look at the 45x squared, y to the third power, and the other denominator, all we need to do is find the least common multiple of those two things. That's what we're doing, okay? So looking at the 45 and the 27, I think I'll just do that off to the side. Remember how we found the least common multiple? Looking at 45, 45 is like what times what?
9.
All right, 45 is 9 times 5. Okay, 5 is prime. And then what? 3 times 3. Okay, so the prime factorization of 45 is 3 squared times 5. Okay. And then, of course, 27 is simpler than that. Because what's 27? Right, 27 is 9 times 3. And then 9, of course, is 3 times 3. So that's 3 to the third power. So if we want to make these the same, and you know what, I should go ahead and do the variables as well. Okay, so what I have is, I have 3 squared times 5 times x squared y to the third power, okay? And then I have 3 to the third power x to the fifth power y, all right? So I've got the blue and the purple, and I need to make them the same. Let me spread them out a little bit. Okay, so it's like we did before. If I want to make these the same, the blue has 3 squared, the purple has 3 to the third power. So what do I do with that? Yeah, make the blue one 3 to the third power. I can only give more, not less, okay, because I'm multiplying. So I have to go with the one that's more. So I'm just going to turn this 3 squared into 3 to the third power instead. Now that part's the same. Okay, and then I see this 5. So what am I going to do? Add 5 to the other side. Okay, so I need a 5 in there on the purple side. So now they both have that. Now I look at the x's. What am I going to do with the x's? On the blue side, I'm going to make this be a 5. Okay? The purple has x to the fifth power. The blue has x squared. I have to go with the more. I can only add more. I can't take anything away. So I'm just going to erase this 2 and make it a 5 instead. Okay, so they'll be the same. Okay, you can only increase. What about the y's? On the purple side, make it 3. Okay? Now, these denominators are the same. So this is the denominator that I have to go with. So by the way, what is 3 to the third power times 5? What is that? 105? 135? Yeah. Okay. So this is the denominator that I'm looking for. Okay, so I need to make both of these fractions have this denominator. So it's got to be 135 x to the fifth power y to the third power on both of them. I don't know how to make this symbol. And, okay, 135 x to the fifth power y to the third power. Now, obviously, I can't just change them, okay, because I can't change the value of the fraction. So anything I did to the denominator, I have to do the same thing to the numerator. Okay? So, How many times does, do this on your calculator real quick. How many times does 45 go into 135? All right, do like 135 divided by 45. How many times did it go? 3 times? Okay, so basically I multiplied by 3. So I need to do that in the top and the bottom, okay? Now let's think about the variables. I had x squared, and it became x to the 5th power. So obviously, what did I just multiply by? I must have just multiplied by x to the 3rd power to make it become x to the 5th power. So I'm going to have to multiply by x to the 3rd power in the top as well. Okay? Y to the 3rd power, that didn't change. Okay? So that's what we have on the left. So that means in the numerator, what's 3 times 13? 39. That's 39. Okay? So in the numerator, I'm going to have 39 x to the 3rd power. Okay? Now that side's ready to go. Now I need to do the same thing to the right-hand side. How many times does 27 go into 135? 5 times? Okay, so that means I multiplied by 5. So I've got to do that in the numerator as well. Now I look at the x's. I see x to the 5th power, x to the 5th power. That didn't change, so I don't need to do anything in the top for that. Then I look at the y's. It was a y, now it's y to the 3rd power. So what must I have multiplied by?
Y squared.
Must have multiplied by y squared to make that happen. So I need to do y squared in the numerator as well. So what is 5 times 17?
85.
Okay, so this numerator then is 85y squared. Okay, now I have like denominators, and I could go on and add or subtract like we did in yesterday's lesson. But we're not going to do that right now because we just need to practice getting like denominators. All right, any questions on number 1? Okay, let's keep going. All right, so on number 2, factoring. All right, we're going to have to factor everything before we make like denominators. Okay, so when you see when you see x squared minus 100, how is that going to factor down?
X plus 10, x minus.
Yeah, that's the difference of 2 squares. So we have x plus 10, x minus 10. Okay, so that's over there. Okay, now over here I've got this x minus 2. And how am I going to factor this denominator? How do I factor this? GCF. Correct. So what is the GCF? Okay, just x and x minus 10. Okay, so now I'm looking at these factors. All right, the whole thing, like x plus 10, x minus 10. Each denominator has to have the same factors. Okay, so the left side has an x plus 10. Does the right side have an x plus 10? No, so I have to give it one. So I have to give it an x plus 10. Okay, if I put it in the denominator, I need to put it in the numerator as well. Let me put parentheses around this. Okay, so I'm going to give it an x plus 10, but I've got to do numerator and denominator, so I'm not really changing anything. Okay, next I see an x minus 10. Does the right-hand side have an x minus 10?
Yes.
Yeah, it's already got one, so it doesn't need another one. They already match. Okay, are the denominators the same now? Why not? Okay, because on the right-hand side, it has this extra x. So that means on the left side, it needs an extra x. Okay? Which means I need to do an extra x in the numerator as well. So that's going to become 3x squared. All right? Any questions so far? Go. All right, if we were actually adding these or something, of course I could write this as 3x squared. And I could multiply these out, FOIL it, whatever you want to call it. But for right now, we're practicing the least common denominator. So let's go ahead and move on to number 3. All right, so looking at number 3, It's all about factoring these so we can see what each side needs to be like the other. Okay, so let's do our factoring skills here. So we have this and this. Yeah, even though there's a minus sign here, we're still just going to find the common denominator, and that's it. All right, so this one is going to factor, this one's going to factor. So let's see, 3x squared. 3x squared can only factor as 3x and x. 5. 5 has to be 5 times 1. Okay, though the 5 might need to go on the other side. So remember, inner plus outer equals middle. So inner, I have 5x. Outer, I have 3x. I'm trying to get a middle of 14. It's not happening. Okay, so that's not going to work out. So I'm going to switch those around, and I'm going to put the I'm going to go 1 times 5 instead. Now inner, I have 1x. Outer, I have 15x. All right, I can get a 14 out of this if I make it -1 and positive 15. That'll give me positive 14. Okay, so there's my -1, and a positive 5 will make the 15. All right, I also have to check to make sure I'm getting -5. Negative times positive is a negative. So that's how you factor that. Any questions right there so far? Okay, so we factored it right. Now let's look at the other one, do the same thing. 3x squared, again, can only be 3x times x. I'll look at the 4. Now 4, it could either be 2 times 2 or 1 times 4. I'll try 2 times 2 first. Inner plus outer equals middle. Inner, I have 2x. Outer, I have 6x. I'm trying to get a middle of 11. It's not happening. Okay, so it must be the other thing. So I'm going to try so that didn't work out. So I'm going to try the 1 and 4 instead. Okay, so keeping an eye on the fact that I'm trying to get 11, I'm going to purposefully put the 4 out here, because that's going to make 12, and that'll give me closer to 11. So inner, I've got 1x. Outer, I've got 12x. All right, I'm trying to get 11. I can get 11 if I have a -1 and a positive 12. So there's my -1, and putting a plus here will make the positive 12. Okay, I also have to make sure I'm getting -4. A negative times a positive is a negative, so that's good. So that's how we factor it down. All right, did I lose anybody so far? Okay, so now that it's all factored, we start looking to see what each one needs. All right, because they have to be the same. So starting on the left, I see 3x minus 1. Does the other side have a 3x minus 1?
Yes.
Yeah, it's right there. So that's good. I don't need to change anything about that. The left side has an x plus 5. Does the other side have an x plus 5? No. So I have to give it an x plus 5 in the bottom and the top. Okay? So that's it for the left side. Now I jump over to the right side. 3x minus 1? Yeah, I got that. X plus 4. Does the other side have an x plus 4? No. So I have to give it 1. So I give it an x plus 4 on the left, in the bottom and the top. Okay? Brrr, brrr. Now all 3 are the same. Okay? So we have our least common denominator now. Okay? That's how you do that. Any questions?
Do we subtract now?
We won't on these 4 because the directions are just to practice finding the least common denominator. When we turn the page, we'll start actually following through. Okay? All right, I'm just going to do one more of these in this video. And then in the next video, we'll start actually solving addition and subtraction problems. Okay, so one more time, we need to factor everything. So I'm going to factor over here, and I'm going to factor over there. Okay? Do this along with me or faster than me if you can. If you're watching this at home, you should pause the video right now and do this problem by yourself. And then run the video and see if you got it right. All right, you've seen me do 3 problems now, so you could probably do this one by yourself. Okay, so 3x squared is only going to factor as 3x and x. Now I'm looking at the 5. That's going to be 1 times 5. Inner plus outer equals middle. So I've got 1x and 15x. To make 14, I need a positive 15 and a negative 1. So there's my negative 1, and a positive 5 will make the 15. Okay, also I get negative 5 because a negative times a positive is a negative. All right, any questions on my factoring there? Okay, now looking at the other one, 3x squared, again, it's 3x and x. I'm looking at the 4. Is this like the same problem we had before?
Yeah, the only difference is the top.
Okay, I'm like, this is looking really familiar.
It's the same thing with
All right, so it was 3x minus 1 times x plus 4. Okay. Let's just copy. I'm like having deja vu over here. Yeah, okay, so I'm not exactly sure what the point is.
it's the same thing.
All right,
Different numerator.
it's different numerator. It's like, okay, it doesn't really change the problem enough to make it worthwhile. It's the same thing. Well, okay, that'll be good because we can just start. We can pick up from where we left off. All right. Anyway, so just like before, we've got 3x minus 1s are the same. This side needed an x plus 4. Okay. This side needed an x plus 5. Okay, and that's enough for this finding the common denominator. All right, I'm going to end this video right here, but we'll pick up with the next example. We'll actually follow through. And I'm seeing that they are some of the same problems, but we're just like getting to finish them. So we'll just pick up from here and like finish some of these problems. All right, this is part 2 of our lesson on adding and subtracting rational expressions that have unlike denominators. All right. So if you didn't watch part 1 already, you have to go back and watch that first because we're picking up from there, and problems that we've already partially solved, we're just finishing them. So you have to watch the other video first. Okay? All right, so in the previous video, we already took this problem and we rewrote it with like denominators. All right, common denominators. So we're going to go from here and go ahead and finish the problem. Now that the denominators are the same, we can put them together into one fraction, okay, using the common denominator of x, x plus 10, x minus 10, okay? And now we're going to have 3x squared minus, now you see that we have this x minus 2 times x plus 10. We need to go ahead and multiply those together. I think I'll just do that off to the side though. Okay, so we've got this x minus 2 times x plus 10. We need to double distribute that, so you know, x times x, that's x squared. X times 10, that's 10x. 10x. Negative 2 times x is negative 2x, and negative 2 times 10 is negative 20. All right, combining these like terms in the middle gives us x squared plus 8x minus 20. Okay, so that's what I'm going to put right here. All right, so I have x squared plus 8x minus 20. Okay, so I need to distribute this negative sign throughout this purpleness. Okay, so I'm just going to distribute this negative sign now. So I think I'm just going to change it instead of rewriting the entire problem. So if I distribute this negative sign, it's going to make this plus become a negative, and it's going to make this negative become a plus. Okay, so now I distributed the negative. Alright, now it's time to just combine all these like terms and see if it's factorable. Alright, if it's not factorable, then we'll be done. So I've got 3x squared minus x squared. So that's 2x squared. And that's it. So I have 2x squared and then minus 8x plus 20. Okay? And I've still got the same denominator. I need to try to factor the numerator for sure.
No, I mean it's denominator. You have to put that all together.
We don't want to do that because imagine that if the numerator factors, and imagine that there's like an x plus 10 in there or something. We want to be able to see what we can cancel out. In fact, we're under no circumstances are we really going to multiply out that denominator. We're just going to leave it like it is. Okay, so I need to factor the numerator. What am I going to do first? Definitely pull out the GCF, okay? So I'm seeing that 2. All right, so I'm going to bring this up here. So I've got 2, and that leaves x squared minus 4x plus 10, okay, over x times x plus 10 times x minus 10. All right, now I'm going to keep going trying to factor that numerator. All right, to see does this factor. Times x minus 10. Okay, x squared, that's x times x. Okay, I don't see this factoring. Right, 10 is either going to be a 2 times 5 or 1 times 10. All right, whether I go 2 and 5, that's not going to make a 4. All right, if I did 1 and 10, that won't make a 4 either. So it's not factorable. So that means we're done. That means we're done. Okay.
So will our final answer be the answer with the 2?
For your final answer, I would accept either one of these things. I would accept this where we pulled the 2 out. I would accept this. Because nothing actually came of taking it out, I would accept this. If someone went crazy and just multiplied all this stuff together and just made it into polynomials with no parentheses, I would accept that as well. I would accept all of that. Okay? Any questions about this one? Okay. But imagine that had factored. All right, then maybe it would have canceled with one of these things in the bottom. And then we'd have to do that. So you have to try. Okay? Now, let's look at the next one. All right, again, in the previous video, we already worked this part out. We already found like denominators. All right, so make sure you go back and watch that. But now we're just going to go from here. So now that the denominators are the same, we can just combine these into 1. Okay, using the like denominator. So I have my 3x minus 1, my x plus 5, and my x plus 4. Okay, now I have my numerators. I have x plus 4 minus x plus 5. But what do I need to do with this minus? I need to distribute it. Okay? So, if I take away the parentheses, what's going to happen to this 5? All right, it's going to distribute and become a minus 5. Okay? So I'm just going to physically change it so I don't have to rewrite the whole problem. All right, so I'm distributing the negative, and that's going to turn this plus 5 into a minus 5. Okay? Then I'm just going to combine my like terms. So I've got x plus x, so that's 2x. I have 4. I'm sorry, I lied. Do not have x plus. I have x minus x. So those cancel out. All right, I have x minus x. So those cancel out. They're gone. All right, and then I have 4 minus 5. Thank you. So that's negative 1. All right, so I'm just going to have negative 1 over 3x minus 1 times x plus 5 times x plus 4. All right, so that would be the final answer for that one. All right, again, example C. In the previous video, we already set up the like denominators, and we're just going to go from here. So since we already have like denominators, we can make one big fraction using the like denominator. However, so 3x minus 1, x plus 5, x plus 4. Now, I see these two binomials up here, all right? And this is like what Lexi was asking me about. We will just multiply both of these out. I'm going to do that off to the side someplace, okay? So over here off to the side, I'm going to do x minus 5 times x plus 4. Okay, so I'm going to double distribute. So x times x, x squared. X times 4, 4x. Negative 5 times x, negative 5x. Negative 5 times 4, negative 20. Wait, this is the same as before. Keep forgetting that. So this is going to be x squared minus x minus 20. Okay, so that means right here I have x squared minus x minus 20. All right, so I'm going to do the same thing with this pair over here off to the side. So I've got 4x minus 3 times x plus 5. Shh, video. I've got 4x. So 4x times x, that's going to make 4x squared. 4x times 5, that's 20x. Then I've got negative 3x and negative 15. So that's going to make 4x squared plus 17x minus 15. All right, so I've got 4x squared plus 17x minus 15. Okay. Wait, did I? All right, so this negative sign has to distribute. Again, I'm just going to do it right here live to avoid having to recopy the whole thing. So I hope you're watching because I'm about to modify, okay? So this negative sign is about to come through and change all the signs here. So if I take away the parentheses, this positive 17 is going to become negative 17. And this negative 15 is going to become positive 15. Okay? And then I will just combine my like terms. So I've got x squared minus 4x squared, so that's negative 3x squared. Negative x and negative 17x is negative 18x. And then negative 20 and positive 15 is negative 5. Okay, so I've got all that. I've got the stuff. Okay, because the leading coefficient is negative, I should factor that out before I try to factor. I'm betting it's not going to factor anyway, but I would be remiss if I didn't try to factor it. So if I take out the negative sign, then I have 3x squared plus 18x plus 5. Okay, and we should try to factor it. I'm betting it doesn't factor though. All right, our best shot is to go 1 and 5. That's 15 and 1. It's not going to factor. It's not going to factor. So that means this really was the answer.